Hey there, I'm your guide from Skill Wanderer, and welcome to this explainer for your Foundations of Computing course. Today, we are doing something really cool. We're going to build a complete image file from absolute scratch. Yep, every single byte, typed out by hand. Let's dive in. So check this out. On the left, you see a simple image, a checkerboard. On the right, that's what a computer actually sees, just a long string of data. So the big question is, how does this jumble of letters and numbers turn into that picture? Well, today we're going to find out by doing it ourselves. Here's our game plan. We'll walk through this step by step. We're going to plan it out, build the file's skeleton, mix our colors, paint the pixels, and then finally admire our handmade image. Let's get started with step 1. All right, section 1, from pixels to code. First things first, let's get our tools ready. You don't need anything fancy, I promise. Just a basic hex editor, any image viewer so you can see your creation, and a calculator to do some simple conversions. That's it. Now, and this is super important, before we write a single character, we have to plan. You wouldn't build a house without a blueprint, right? It's the same idea here. We need to figure out the exact size and structure of our file, down to the last byte. This is absolutely critical. Okay. Let's do the math. Our image is 4 pixels wide. We're just using black and white, so each pixel is just 1 bit, either on or off. That's 4 bits for a whole row. But here's a little technical quirk with BMP files. Each row of data must be a multiple of 4 bytes long. Our 4 bits don't even make up 1 full byte, so we have to add what's called padding, basically just empty data, to round each row up to 4 bytes. 4 rows at 4 bytes each gives us 16 bytes for all our pixel data. Add in the file headers and our color info, and we get our final number. And that number is 78. 78 bytes. That's it. Our entire little checkerboard image will be perfectly described in just 78 bytes. If we end up with 77 or 79, it just won't work. The file will be corrupt. This is a great lesson in computing. Precision is everything. Okay, our blueprint is done. Now it's time to actually start building this thing. We begin with the headers. You can think of headers as the instruction manual for the file. It's what tells any program, hey, I'm a BMP image, this is how big I am, and this is where the picture part starts. The very first 14 bytes are the main file header. It always starts with 4240D. In text, that's just BM for bitmap. It's like a signature. Then we have our file size, 78. But look how it's written, 4E0000. Kind of weird, right? That's because of something called little endian byte order. It just means the smallest value comes first. It's like writing a date as day, month, year instead of year, month, day. It's a common computer thing. Right after that comes the 40-byte info header. This is where we put all those details from our plan. You can see we're telling it the width is 4 pixels, the height is 4 pixels, and that we're only using 1 bit for each pixel. This also tells the computer that we're going to need a color palette with just 2 colors. Speaking of colors, that brings us to section 4, defining our palette. The file structure is there, so now we need to actually mix our paints. And since it's a 1-bit image, our palette is about as simple as it gets. We just need black and white. And here it is. Color 0 is black, all zeros. Easy enough. Color 1 is white. That's FF, which is the maximum value for each color. And here's a fun little piece of trivia. BMP files store color in BGR order, blue, green, red, not the RGB you might be used to. It's just a little quirk you have to remember. Okay, here we go. This is the fun part for real. We've built the frame, we've defined the canvas, we've mixed our paints. Now, it's time to actually paint the picture using raw data. But wait, before you type anything, you have to know the single most important, most confusing, most often forgotten rule of BMP files. The pixel data is stored upside down. We build the image from the bottom row and work our way up to the top. This trips up everybody at first, so please burn this into your brain, bottom to top. So let's start painting at the bottom. Row 0. For our checkerboard, the first row needs to be a black, white pattern. Now, think in binary. If 0 is our black color and 1 is our white color, that pattern is just 0101. And if you convert the binary number 0101 to hexadecimal, you get 50. So we write 50. And then we add 30 bytes for that padding we talked about to make the row a full 4 bytes long. So that's our first pattern. For the checkerboard to work, the next row up, row 1, needs to be the complete opposite. White, black, black. So let's figure that one out. A white, black pattern gives us a new sequence. In binary, that pattern is 1010. Convert 1010 to hexadecimal and you get A0. So the second row from the bottom is A0, again followed by our 3 padding bytes. And those are our 2 building blocks, 50 and A0. And now we just repeat the pattern. It's easy from here. Row 2 gets the 50 pattern again, and the very top row, row 3, gets the A0 pattern. And just like that, our 4x4 checkerboard grid is digitally painted. And that is it. Seriously, you have just constructed a visual image file 1 byte at a time. So let's review the final product and go over a few things to check if you run into any snags. Here it is, the whole shebang, all 78 bytes in a row. Go ahead and pause here, pull up your hex editor, and compare your work against this. Every single character should match perfectly. Now, if you save your file and it doesn't open or looks all weird, don't worry. It's almost guaranteed to be one of these common mistakes. Did you remember to write numbers in little endian format? Did you add the padding to every row? And please, 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 did you build the rows from the bottom up? Check those things first. Look, finishing this assignment is awesome. But if you really want to make sure you've mastered this, try these challenges. How would you change the binary to make vertical stripes? What would you have to recalculate to make an 8x8 checkerboard? This is where the concepts really click. Think about what you just did. You didn't use Photoshop or some fancy library. You spoke the computer's native language to describe a visual idea. You've learned how a machine fundamentally sees. This is such a core skill. So I'll leave you with this question. Now that you can literally write an image, what will you create?